Hey, Miles. Hey, Miles. What sound does a horse make? Neigh! You like that? Here. Neigh! I'm Mr. Maze the horse. Neigh! Neigh! All right, hello, legends. Today, of course, we will be looking at the Unit 7 Pro Tips. I'm going to go through these concepts relatively speedily because the majority of the point of this video, of course, is to highlight the interconnections I want you to put more time into to make sure that you do brilliantly on this exam. Now, as we know, the Unit 7 exam is going to be a difficult exam. And I've not only because it's a difficult concept or a difficult set of concepts, which it is, but perhaps most importantly, because I have upped the rigor level, and that's just to show you the number of brilliant things you are capable of doing when you really set your mind to it. When I say up to the difficulty level, though, I want in this video to assuage your fears. I don't mean I'm putting a bunch of stuff in there that you just wouldn't know how to do. If anything, it should be stuff that really piques your interest in your mind and makes you go, oh, wait a minute, we talked about these ideas. I've worked with these ideas. I think I can walk my way through it, okay? Now, that doesn't mean I'm not going to be giving you some of the traditional types of questions. In fact, I will. So let me walk you through this framework. And I would say, of course, my first piece of advice is, and I heard that you heard me say this several times in class, know everything. Inside, out, and backwards. And of course, you're not going to be writing this down because that's a saying and an expression, and it's not entirely relevant to the course. But what I want, of course, is for you to take these ideas that we've talked about and that we've learned about, and in similar ways to how it appeared in the review guide and also a little bit in the Frappy, and then, of course, in problems we've done in class, notice the ways in which these ideas can be used and worked with and how they interrelate, right? So a great example of that, which we'll go over, of course, is that type 1 and type 2 errors are inversely related, right? As type 1 error likelihood goes up, type 2 error likelihood goes down, right? And then, of course, the ways in which, like, type 2 error probability is the complement of power, right? Level of power plus odds of a type 2 error add up to 100%. So we will go through, of course, all of these things, but I would say just know your stuff, right? And then second thing that you should do is watch the video notes. That ties pretty directly in with knowing your stuff, but do it. Go through the video notes to make sure all the concepts make good sense. And then, of course, thing 3 is Unit 6 stuff could appear. So I would say go over it. And actually, I'll tell you right now, it will appear. And the big things from Unit 6 you should know are panic, right? Interpreting confidence interval versus interpreting confidence level. Okay, now we went over these in class, but interpreting confidence interval, so the interval version, is simply we are blank percent confident that the true parameter, not the sample mean, not any, the true parameter, right? Or the true mean of blah, 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 or the true proportion of blah, 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 lies between, and then you give your lower and your upper end. That's interpreting confidence interval. Interpreting confidence level is the one that we went over in class once again, but that we, of course, went over last unit, which is if we took many, many samples, all of the same size or all of sample size, and then they give you the value, and we constructed blank percent confidence intervals for each of them, we would be fully confident, right? We would be confident that around blank percent of those intervals contain the true population proportion or the true mean, right? All of those are in your previous notes. You should have those. You should know them, but I've just said them verbally to you, so you have them on top of all of that. So that will be a big part, that and knowing how to run through the steps of panic, right? And remember that panic comes about when it says construct and interpret, a confidence interval for whatever. Beautiful. So know your stuff on that. Definitely, because some previous unit stuff is likely to come up. Fourth thing that you should be aware of. You notice I'm doing this in orange, favorite color, right? We're going to rock and roll. Well, orange and purple, I guess, are the two that I think are the best. Okay, what should you do? Here's some things that are really important to do. I mentioned this briefly, but type 1, type 2 errors, and then power, your alpha, also known as your significance level, in contrast to confidence level, right, which is for confidence intervals, but that's why we call them levels. They set our standards. And then, of course, this idea of the distance between the true parameter and the hypothesized value. And the hypothesized value is always either the null proportion or the null mean, right? So you'll remember when we set, I'm going to go in reverse order. We'll start with this idea of the distance between the parameter and the hypothesized value. The parameter, whatever it is, be it a proportion or the true mean, is just a value. All right, so I'm just going to say the true proportion or the mean, right? And we know that for a null hypothesis, we're always saying the true proportion equals, right, the null p, or equals the null mean, okay? And what this concept is touching on, that we touched on briefly, is that the further apart those values get, right, the further away your null is from the actual answer, right, the higher your power level will be. And the reason for that is it will be easier to reject the null. So remember that the further away the null is from the true hypothesized parameter, the more likely you're going to be to reject the null, because the null will be far away from the answer, right? And the closer the null is, well, the harder it will be to reject the null, because obviously it's close to the answer. And that should make perfect sense. So the closer the parameter is to the hypothesized value, the harder it's going to be to reject it, even if it's wrong, because it'll be so close to the value that it's difficult to reject it. So know all the ways in which that interrelationship could play, right? Similarly, know how your alpha works, right? Know that your alpha is literally the probability of a type 1 error. And remember that a type 1 error, right, and this is all in your notes, but you should remember the probability of a type 1 error is, we remember type 1 errors as alt people, right? So rejecting the null wrongly. On the other hand, we have a type 2 error, and we should know that a type 2 error is old people, right? They fail to reject the null, also wrongly, right? So in their case, they fail to reject the null when actually the null is false. I should say the null, that looks like an alt. They fail to reject the null when the null is false, versus a type 1 error is you reject the null when the null is actually true. We should remember that the probability of a type 1 or a type 2 error plus power level equals 1 whole, right? And because they're complements of each other, this rule will extend to, 1 minus the power level equals the probability of a type 2 error, and 1 minus probability of a type 2 error equals your power level. All this should make sense, right? You will be asked, of course, to interpret power level. What is power? Well, power level is defined, as it were, as given the null is false, the probability of rejecting the null is your power level. So again, power level, pretty straightforward concept. Should feel at this point, right? What is your power level? Well, your power level is to say, if we given that the null is actually false, right? We know in the real world, we happen to know that the null is false. If that's true, the probability of rejecting your null is just your power level, right? So the odds that you will successfully reject your null, given that the null is false. And we're given that value normally, or we're given your probability of a type 2 error, and then you calculate accordingly. Okay, so we've got all that rolling. We know what our alpha is, right? Our alpha is our benchmark. It is the odds of making a type 1 error, aka the odds that we reject the null incorrectly. And so it's just a great look at all of these concepts. Make sure you know how they interrelate. Go back through the notes on these. There will be a fair number of questions, I should say, on type 1 and type 2 errors, power levels, and obviously knowing, right, your significance level and understanding. There will be maybe 1 or 2 questions about understanding the difference between the parameter and the hypothesized value. But definitely lock in on type 1 and type 2 errors, know what power is and know how to interpret power, as it were, and know significance level. Okay, we're on 5. What else should you be able to do? Well, you should be able to interpret a p-value. And you should know what a p-value is, right? How do we interpret a p-value? Here's what we write when we say I am interpreting a p-value, assuming the null, and then you give context for what the null represents, is true. So we assume the null is true, right? Because that's the whole idea of how we run these calculations. So assuming the null is true, the probability, right? So of getting our sample statistic or more extreme. Is, and then you would just write whatever the p-value is for a particular problem. Again, I went through this in the notes. I'm not going to spend too much time on this. You should know this. And if you feel like you're sloppy on this, go back through the video notes. Practice, practice, practice. Know what a p-value represents. This is why we do all these little sketches where you then set up your test statistic. And that's another side note. Know that your test statistic is either the t value or the z value that you use to find where your sample statistic would sit, or on a sampling distribution made up where the center, right, is the null hypothesis. So with that in mind, know that the p-value is, let's say if the p-value is greater, then the low end will capture it all the way up to the high end of 100,000, and the p-value are the odds of getting your sample statistic or more extreme in this particular sketch that far to the right, as it were. And then, of course, the opposite. But all of that's in the notes, so you should know that already. That's something to review. Interpreting a p-value and knowing how to understand a p-value in various scenarios, right? So know what it would look like in a sketch to have a p-value where the value is greater than, right, where we're saying the parameter is greater than the null, where the parameter is less than the null, and where the parameter is not equal to the null. In this case, the p parameter looks like I'm talking about proportions, and insensibly so you would say the same thing for means, right? Or does not equal the mean. Rock and roll. Okay, so be able to know all that. Go back through, and again, I'm not going to go into detail on it here, so go back through the old video notes if any of that feels sloppy. All right, that should feel pretty solid so far, right? Obviously be able to, and I said this earlier, but be able to define a confidence level and a confidence interval from Unit 6, and be able to do the steps of panic, right? Go back through the video notes for that if you have any struggles with it, but know how to do panic, every single step, and how to apply it. Know how to interpret power, know how to interpret p-value. Sorry, I'm just going through my list because I want to make sure we hit on all the beautiful stuff. This is a big one. Part 6. No phantoms. No phantoms inside out and backwards. Know how to take phantoms and use it to break down a hypothesis test, okay? And know that phantoms will come up when I say, is there convincing evidence, right? When you see convincing evidence, you know you are going to be running through phantoms and doing a hypothesis significance test, right? And there are so many parts to phantoms. Know every single aspect, right? Be able to define in your parameter whether we're dealing with proportions or we're dealing with means. Allow that to take you all the way through. Run your hypotheses, right? And I'll go over this in a moment, but be good at defining your hypotheses. Know what the null would be. Know what the alt will be, right? List your assumptions always. Always list them do not go without that unless I deliberately state that you can assume that they're dealt with. Name the test. Know if it's going to be a T1 for, know that it's going to be one where we do a t-test statistic if it's for means and we don't have the standard deviation for the population. We just have the standard deviation for the sample, right? Or on the other hand, if it's for proportions, it's going to be a z value, right? That we do for our z-test statistic. Then know how to do T and O, either in your calculator, but then also by hand, because there will be multiple choice questions where doing it by hand is required. And then M&S, that's where you do your conclusion, right? So that's where you state p-value is greater than the alpha, and if the p-value is greater than the alpha, then we, or equal to the alpha, we fail to reject the null, or the p-value is less than the alpha, and those are the situations where we say p-value less than the alpha, therefore we do reject the null. And there is convincing evidence for the alt. All those phrasings are sitting in your notes, so do go through them and no phantoms. Like I said, there's going to be some FRQ where I give you the intro and I just say, is there convincing evidence for blah? And I just give you a whole page and you go through and you'll run phantoms and you'll do brilliantly. I have no doubt on that. Okay, like I said, be able to construct a confidence interval and use panic. We're nearly there, guys. Part 7. Okay, know how to find a test statistic. Know that when it says test statistic, just a review on this, because there's so many words in this class. It's either going to be the t-test statistic or the z-test statistic. Know that we use t. Oh, I already wrote this up above. Know that we use t when we do not have the population's standard deviation. We use t. We use t when we only have the standard deviation of the sample, right? And that's for means. And know that we are going to use z if it's for proportions. Know how to solve it. Be aware, of course, that for the proportions calculation, it will look like this, where the square root underneath that gives you standard error is going to have the sample size from your sample, but you will be doing the null proportion times 1 minus the null proportion. Don't make the rookie error of throwing your p-hat in the wrong place or throwing your null proportion in the wrong place or any of these things. So know how to calculate the test statistic, like just the test statistic on its own, because those formatted questions will arise, okay? And also, where this whole thing is the test statistic, right, for a proportion. But also, know how to do the other part of that, which is how to find, and we'll call this part 8, know how to find a p-value using a test statistic. So we went over this in the 7.3 homework, but know how to, and also we went over it obviously in 7.1 and 7.2. But be able to find a p-value using either normal CDF, if we're working with a z-test statistic, or t-CDF, if we're using for a t-test statistic versus a z-test statistic. Okay, and this is the thing where I was talking about it earlier. Make sure you know your lower bound versus your upper bound. And the way I go about that is I sketch. You saw it in the way I went over the 7.3 notes. I think it's super, super important. And then you'll, of course, do degrees of freedom. Degrees of freedom is n minus 1 when you're doing the t-distribution. But you'll do a mean and a standard deviation for this one. And, of course, the mean will be 1, or just kidding, 0. And the standard deviation will be 1 for the Z1. Hopefully you caught me there when I was like, the mean will be 1, and you're like, Mr. Mays, man, you can't be messing up like that. Okay, so you should be good to go on all of that. Be able to understand it directionally, right? If your t-test statistic or your z-test statistic is positive, in both those cases, that's probably the upper tail that you're catching, right? Because they are to the right of the mean, which will always be treated as 0. And so you'll use that as your lower bound, right, in those situations. If on the other band, right, so that'll be lower bound and then upper bound. If on the other hand, your t-test statistic is negative or your z-test statistic is negative, that'll mean the mean was around 0. The t or z-test statistic will be to the left of that value. And so it will be the upper bound to a lower bound of some very low number like negative 100,000. Again, I always do these sketches. And so when I run through this kind of work, it's super important for me to say to you, don't just memorize it. I know there's that desire to just like plug it into your brain and spit it back out. Don't do it. Understand the way these things are functioning together so that then if something slips your mind, you still know what you're doing and you can walk your way back to the truth. And in that vein, if I end up with a positive t-test statistic and I'm using that and they say, what about does not equal? I'm going to find the upper bound and then multiply by 2. On the other hand, if I get a negative t or z-test statistic and I'm like, oh no, I need to do a two-tail, I'm going to find the lower bound and then I'm going to multiply by 2. Okay, that should all make perfect sense. Know when to use t, know when to use z. That should be pretty straightforward. Honestly, we're basically there, guys. Here's what I'll say. Don't let AP or me mess with you, okay? Don't let us scare you, okay? Know your stuff. Okay? Remember that you know your stuff. Go through it because there will be answer choices that sound convincing just because they have a lot of words in them. Don't pick that. Pick the one that actually expresses the idea that you're looking for, okay? So, you should be comfortable with Unit 7. I've given you my hints and pro tips of everything to go through. The big things for the FRQs, of course, will be going through phantoms and knowing that inside out and backwards and being able to interpret a bunch of things. Because I'll say something like interpret a p-value in context, interpret the power level in context, interpret a type 1 error in context, interpret a type 2 error in context. And you can expect those kinds of questions and those kinds of definitions to show up in the multiple choice as well. So make sure you know it. All of it, and ask me questions if any of that peeks out to you as a problem, right? The video notes I did on 7.3, 7.2, and 7.1 go in a lot of detail as well, so that's what I'd recommend doing for that. Know how to calculate your test statistics. A T1 only when we're doing means, and we only have the standard deviation for the sample, which is more often what you'll find, but remember that's when we do a t-test statistic. Okay. On the other hand, do a z-test statistic if for some reason you end up with a mean question where we have the standard deviation for the population. Or, more often than not, do a z-test statistic when you're messing with proportions. Know when you're messing with proportions versus when you're messing with means. Be able to calculate a p-value using a test statistic. Know to use TCDF or norm CDF. Know if you're finding an upper bound, lower bound, or a lower bound, upper bound. Know what the sketch would look like and know what it is you're doing. Identifying things in context is going to be big here. There will be a lot of multiple choice questions where you have to identify a null and identify an alternate hypothesis. So know from the way that questions are worded what the null would be. Remember that the null is always equal to something. It's never greater than. If it says we think the value might be greater or we suspect it's greater than a percentage, the null will be that it's equal to that percentage or equal to that mean. And the alt will be that it's greater than, etc., right? Different would mean does not equal. So know those different functions. Know the power level, right? And be able to interpret it. What's the power level? Well, given that the null is false, and then you should give context, it's the probability or the percentage of the time that we successfully reject it. So it's the percentage of the time that when we're trying to reject the null, we do it, and the null is actually false, right? The odds of committing a type 1 error, right? Are your alpha. That's the percentage of the time that you risk rejecting the null incorrectly. And then know that your power level and your odds of a type 2 error add up to be one whole. But remember also that the probability of a type 2 error and the probability of power are both based around the idea that the null is false, right? So you have to have the given that the null is false in order to have the probability of a type 2 error add up to your power level, right? Yeah, I mean, guys, I really think you guys are going to nail this. Remember to go back through Unit 6. No panic. You will, on one of the FRQs, have to construct a confidence interval. I guarantee you. You probably will not have to do every step of panic, although I might throw that in there. But you'll definitely need to be able to construct a confidence interval and then interpret it. Know how to interpret confidence level versus confidence interval. Do not mix them up. Do not get them wrong. The way that you do that is not just by memorizing the concepts and the definitions, but by remembering that confidence level is talking about what does it mean to be that confident, versus confidence interval is talking about, just tell me how confident you are. I think we did it, Legends. I think we did it. Go through. If any questions arise from watching this pro tips video, shoot me a message, right? If you're unsure on anything here, go into more detail, watch the video notes, shoot me messages, practice, practice, practice. And again, like I said, I'm already giving you a lay of the land. You should have a vague idea as to the kinds of questions you should see on the multiple choice. I've hinted at just about all of them, right? Though you can't be sure exactly how they're going to show up. And then, of course, I've hinted at about half of the FRQ. You're going to have a phantoms problem. It's going to be pretty vague, and you're going to have to run the whole setup on it, right? Excuse me. And then you're going to have to do some kind of panic problem as well, right? Know your interactions between type 1, type 2 errors, between power, between alpha, between all of these things. And understand this idea of the distance from the parameter, right? You're going to do brilliantly. Watch out for the language, for the way that things are phrased. Look in your language to make sure you're being specific. Don't add in extra words. Know a sampling distribution. Know all these beautiful concepts and make sure they have melted together in your brilliant minds. Okay, that's, I think, all I've got for you today. I'm proud of you. Do not be discouraged. Fight hard and come with a victory, okay? Study, study, study. I am so proud to be your teacher. I am so thankful for you. Put the time in. This is Mr. Mays signing off.